Now, I've tried to make a case for E and the simplicity of the continual compounding formula. That's not quite the same as saying we know where that formula comes from or how E can fit in where it doesn't quite match what we understand. I think we sort of familiar with this equation. We can kind of remember where that came from in our study of interest problems. That one we get, but it's not quite equivalent to this one, even if this one is more useful and easier to manipulate and will produce simpler and more straightforward answers than the one we understand. We don't quite know where that came from, and it's always good with mathematics to keep returning to the basics so you know what you're doing. I do this all the time. So to go way back, how did we get this somewhat complicated formula from working on interest problems? Well, we did it just by building up the arithmetic in a way that we knew would get us the would get us the answer if we invent a problem. Okay, so you have a $200 investment and it's going to earn 4% for a period, say a year. What is the simple interest? Well, no problem there. We take the principal, or the future value is going to be the initial principal plus the initial principal times the interest rate. Add that all together and you get the amount. But what if you go on another year? Well, you'd get $216. You'd have another year's worth of interest. But of course, we're interested in compounding problems. So then we have to say, well, what will we get the next time around? Well, at first, we got this. And then when we calculated the next amount of interest, we had to remember that we'd already gotten this, and we have to multiply this by the percentage rate, which is how we got those extra 32 cents there, because that's the interest on the interest. And we can keep that going. If you want a third year, then you take everything that the investment has earned already, and you also multiply that by the interest rate. But this is clearly unworkable. We could maybe get as far as 3 periods, but for the actual problems of growth in finance or anything else, it isn't going to work. And so we developed this formula, which is the same as our compound interest formula, by taking out repeated things in a convenient way. And I don't want to go through the algebra to see exactly how we know that this gnarly mathematical sentence is equivalent to this simpler one. But what we are doing, I want to remind us, is to pull out complications that can be removed and therefore simplify the whole. So one simple thing we did is we took the principal out and replaced it in the repeated formula with this number 1, which we could then raise to a power. And in order to get this, we will keep that trend going. We will pull out what can be taken out of the more complicated parts of the formula to make the whole thing more workable. So for this, although we don't see it yet, E is going to be very useful. Always remember your definitions. This is what we mean by E. It's that figure if we raise what's in the parentheses to the power of n, and what's in them is 1 plus 1 over n. Then as n goes bigger and bigger and bigger, E also grows bigger, but while n goes up toward infinity, e stays a small number, always less than 3. And so we are now on the hunt. How can we get from this if we've started with that?